Hello students, welcome you all to the VT app. So for this video, we want to see kind of the waveguide that is called a rectangular waveguide. Okay, before I had to started this topic, you must know what is a waveguide. A waveguide is a kind of metallic tube which can be propagate that electromagnetic energy from one place to another place. Actually, it is a kind of a transmission line. In the previous videos, we have already seen what is a transmission line. A transmission line is a conductive path of guiding electromagnetic energy from one place to another place. Okay, so out of all the transmission line, when power is a very important parameter for power handling, we are using waveguides. No other transmission line gives you to accommodate highest amount of the power. Only the waveguide which gives you the best means of communication, especially the highest amounts of power, right? Yeah. The one kind I have, the rectangular waveguide. The definition it is, a rectangular waveguide is a hollow. Oh, what is the meaning of that hollow? There is a empty inside. Okay, so hollow metallic tube with a rectangular cross section. So very important definition about that rectangular waveguide. A rectangular waveguide is a hollow metallic tube with rectangular cross section. Look at this, what I have written on this. This is the rectangular cross section is there. Okay, so look at that diagram on you. This is the structure of a rectangular waveguide. Look at that the shape we have written here. It is a rectangular. For the rectangular, the adjacent sides they are equal. Okay, so all that the opposite sides they are equal. That is called the rectangular shape. The conducting walls, this word is important. The conducting walls of the waveguide confine electromagnetic fields, because the walls of a waveguide, they want to be take that electromagnetic energy and guide the electromagnetic wave. Okay, so earlier in all the transmission lines, we say they need to be produce the electromagnetic energy in the form of the electric field and magnetic field. Okay, both their combinations will be possible, but in the waveguides, the conducting walls of a waveguides, they have to confine the electromagnetic fields and they want to be transmit, okay, thereby guide that electromagnetic wave in a particular direction. Look at that the structure what I written there. Look at that, this is a rectangular waveguide of the shape like this. Okay, so this is a rectangular fashion. I have a length of the waveguide, the length of A, and it is having the width of B. Now there are the two parameters which can decide what the shape it is exactly. Okay, so A and B, and they need to be arranged in the terms of the three-dimensional representation. Okay, so there is a Z, there is a X on top side, and there is a Y on down side. Okay, so this is the three-dimensional representation. In the three-dimensional representation, we can say how the wave is propagate inside the waveguide. Okay, then we see electromagnetic wave that can propagate inside by reflection from both of the sides. So there are the two sides are there, 1, 2 now. Okay, there is any reflection from this, then only the electromagnetic wave can propagate. Because of the electromagnetic wave sides, they want to be reflect. Because of that reflect only, your electromagnetic wave can propagate. That is a very important point regarding that rectangular waveguides. What are the two parameters affected? The length as well as the breadth itself. Okay, so A and B is given to you now. This is the length and this is called as the breadth itself. Okay, then what are the uses where you find the rectangular waveguides? The rectangular waveguides, they are very important for the microwave components, that is called isolator, and detectors are there. Okay, and attenuators, and finally the couplers, directional coupler we are using there. For all these, the inner methodology we are applying is the rectangular waveguide. Isolator, detectors, attenuators, couplers are available various standard waveguide bands from between 1 gigahertz to that almost 22 gigahertz. So all the waveguide, the applications, they are in the range of 1 giga to 22 giga. They are huge applications like isolators, because what the best way we can accept that electromagnetic energy, that is important for this. Okay, then a simple topic called the modes in that rectangular waveguide. What are the modes in a rectangular waveguide? Yeah, look at that. There are the two modes that are possible: transverse electric and TM, transverse magnetic. These two modes are accepted in waveguide. Okay, transverse electric and transverse magnetic are supported in rectangular waveguide, but TM mode is not accepted. Very important bit for this online. Why TEM mode is not accepted in a waveguide means because there is only one conductor in that particular TEM. Because of that reason, the TEM mode of operation or propagation is not allowed in waveguide, but it is possible to have the TE, transverse electric, and as well as transverse magnetic, right? Okay. For each waveguide mode, there is a definite lower frequency limit. Okay, so what is that? This lower frequency limit, below that frequency energy is propagated. Above that energy, above that value, it never allows that EM energy. Accepted? So what is the limit for me to accept that EM energy, electromagnetic energy, that is called, okay, the lower frequency limit called cutoff frequency. Okay, so for cutoff frequency below this, no signal can propagate. Okay, so that is what I mentioned to you. And the number of possible modes, suppose how many modes we are accepting. Okay, TE of the different kinds, TE01, TE20. Okay, so these are the different kinds. How many modes that are accepting means that increases with the frequency. If you increase the frequency, definitely the modes also increasing. Okay, it accepts that more number of modes inside that waveguide itself. Okay, so there is only one mode possible called dominant mode. Dominant, the word is very important. What is the dominant mode? For lowest frequency that can be transmitted. Okay, the dominant mode means below that frequency only we are accepting that the electromagnetic energy can be transmitted. Look at that, on the three-dimensional plane I have X gives me, okay, suppose let us think I have a electromagnetic wave like this. Okay, so this is my electromagnetic wave of it is like this, because they are transverse to each other. That's why I give to you the second wave is completely slant of the first wave. Right, this is the electric field and this is the magnetic field. Completely they are perpendicular to one each other. Look at that, on my assumption it is moving along that x direction. Your electromagnetic wave is moving along that x direction, and your electric field is along that y, and your magnetic field is along that z direction. Okay, can we accept the same point on this? Okay, so direction is along that x direction, electric field is along that y, and magnetic field is along that z direction, right? Okay, so regarding the TE now, can we accept? Every time please you mention TE MN, M for the row and N for the column. Okay, so almost here what is the value of this one? TE11, right, where N becomes 1 and N becomes 1. This is TE11. Okay, so look at that, this is what we call, this one is called that electric field, and what this one is called, this vertical line which we call the electric, and horizontal line which we called as the H field, magnetic field, right, where this is called the TE11. And coming to the TE21, look at that, what are these two now? Okay, M becomes 2 because of this is a 1 2 and this is another way. So M, how many we have there? M becomes 2 and N becomes 1. That's why it is a TE21. Okay, so this is called the dominant modes of transverse electric field itself, right? Okay, then we move to that one more part on this, the TM. On the TM we have there, yes, this is the center part on this, the circles which gives you on either direction, where M is equal to 1, N is equal to 1. This is called TM where 1 1. Okay, TM 1 1, and also it is also possible, look at that, the dotted lines. For M we have how many rows are there? there are that. The columns, how many are there? There are 2. And how many rows there are there? 3. So finally we call it as TM23. Why the TM10 and TM01 modes are not possible, okay, on this mode? It is like accepts only TM11 and TM23 itself, okay. So in this particular video we are understood the concepts of rectangular waveguide and its structure, as well as the modes of dominant modes of transverse electric and transverse magnetic waveguides. Okay, so in the next video we'll see the very important topic on exam, that is the wave equations for rectangular waveguide. Thank you.